Question 6 is all about logic, and we are asked to complete the following truth table. So first up, we are given P, Q, P or Q, and then we are asked to find not Q. So remember, if we're given Q in this column here, not Q is in effect going to be the opposite. So if Q is true, then kind of by default, not Q must be false, and we can say the same here. So if Q is false, then not Q must be true, etc., etc. So essentially, they're going to be opposites. The next column then is P and not Q. So what we're going to do now is look at P and not Q and say, are they both true? And they're not, so that's going to be false. The next one, we've got P and not Q. Those are both true, so that's going to be true. P and not Q are both false, so that is false. And similarly here, P and not Q, they're not both true, so therefore that is false. Next up then, we have got not P or Q. So again, the kind of shortcut that we can do here is do the reverse of the signs. So if P or Q is true, then not P or Q must be false. And similarly, we can complete the rest of the table like that. And then finally, we are asked to complete the truth table for P and not Q implies not P or Q. So let's have a go at this one. So P and not Q, so that's this column here, implies not P or Q, that's this column here. So remember when we're looking at the implications, in the first instance, the initial statement is false. And what this statement here is doing is saying, if P and not Q is true, then this will happen. But this isn't true. So we can't we can't kind of disprove this. So our default is that we say that is true. Now for the second example, it's true, so we can test it. So we do have P and not Q, that's true, and we don't end up with P not P or Q, because it's false. So that one contradicts this statement here. Similarly, in the third instance, the initial statement's not true, so we can't negate that, so we just assume that's true. And similarly, in the final statement, that is not true either, so we say that that must be true. So that is going to be the truth table, and in part B we're asked to state whether this statement in this column here is a contradiction, tautology, or neither. A logical contradiction would have all false, a tautology would have true, and we can see that clearly we've got a mixture here, so the answer is going to be neither.